Hi everybody, welcome to AD3301 Data Exploration and Visualization, Unit number 1, Exploratory Data Analysis. So in this video, we are going to discuss about important and frequently asked questions. So let us start. The first question is, define exploratory data analysis. So what is EDA? Okay, we are going to write. And also, we are going to write what are the steps available in EDA. So this will be the answer for this question. Okay, now, so let us start. What is EDA? So EDA is an approach. Okay, for what? For analyzing and understanding what? Data sets. So I need to understand the data set. I need to analyze the data sets. So there are plenty of data sets available. So it is an approach. So EDA is an approach to analyze and to understand the data sets. Then by visually, so that means we can create some charts, okay, and also some statistical information we can get it from the data set. So this is the main aim of EDA. Then the goal of EDA you can see here to explore the underlying structure. So what is the structure of your data set? What are the patterns available in the data set? What is the relationship between the variables? There are plenty of variables available in your data set. So we can find the relationship between the variables, okay, within the data, and before applying more formal modeling techniques. So before applying the modeling techniques, so we can study about the structure of your data set. You can study about the pattern of your data set, the relationships. So all these things we can study by using the EDA. Then EDA helps in identifying the anomalies. So anomalies means something abnormal. Okay, so with the abnormals which is available in the data set, and then assumptions. What are the assumptions made in the data set? Testing the hypothesis and understanding the distribution and the relationship among the variables. So this point already we discussed here. So the distribution of the variable and the relationship among the variables. So all these things we can study about a database by using EDA. Okay, so this is the proper definition for EDA. Then you can see the steps. What are the steps available in EDA? So totally there are 5 different steps available. The first one is a problem definition. So what is problem definition? You don't need to write it here because it is only a 2 mark question. Okay, we can learn about what is problem definition and all in the part B. I mean the long answer questions we can see. Then second step is a data collection. Third one is a data analysis, model development, and then result communication. So these are the 5 different steps of EDA. So the second question is, what is meant by EDA? So this is also almost related to the previous question. So if you understand the previous question, question number 1, so you can answer this question also. Okay, so we can see what is meant by EDA. So EDA refers to a process of analysis and visualizing the data to summarize its main characteristics with the help of statistical graph, plots, and data visualization tools. So the main concept is analyzing and visualizing the data. So it is a process. EDA is a process of analyzing and visualizing the data. So we can generate everything, all the things, that means the graph, plots, the data visualization, using the visualization tools, we can do everything. Not only this, so it is going to find, okay, it is going to uncover, okay, it is going to discover, we can say, the patterns available in the data set, then the relationship between the variables in the data set, the trends and the anomalies. Okay, all the points we already discussed in the previous slide. That means the first question, so almost the points are repeated. So if you understand that, you can write this. Okay, that means second question also you can write. Now, I'm giving the key goals of EDA. So the first is understanding the data, identifying the patterns, detecting the outliers and anomalies. So what is outliers? We will discuss in some other question. So anomalies, I already told it is abnormal things. Then testing the assumptions and pre-processing the data. So this is question number 2. So 1 and 2 are mostly related. Now, question number 3. What is the significance of EDA in data science? So data science is a major field. So in the data science only, we are having the EDA. So what is the importance, the significance of EDA in data science? So EDA is a fundamental steps in the data science. So in the data science overflow or workflow, if you take, okay, so EDA is a basic thing. It's a first step. Now, its significance lies in it, it helps in the data scientist and data analyst. So EDA is going to help, okay, the data scientist and data analyst for what? To understand the data, and to uncover. So all these things we already discussed in the previous slide. So to uncover the patterns, the issues, this is the anomalies, and to prepare the data for the future analysis and modeling. So what we understand here means EDA is going to be the first step in the data science workflow. So a data scientist or a data analyst must understand the data by using the EDA, then only further analysis he can do. So the reasons why EDA is crucial in the data science. So we are giving some points here. So why EDA is significant or important in data science means these are all the points. So underlying data structure, understanding data structure, you can learn about the structure of the data. So what are the data types available? How many fields available? Okay, how the fields are related with each other. So all these things we can understand by using the EDA. Detecting the data quality issues. So this is related with the abnormalities. That means anomalies, abnormal. Then guiding the data cleaning and processing. So if data needs cleaning or no need to clean the data. So all these things we can understand only by using EDA. Identifying the relationship between the variables, forming the hypothesis and directing the future analysis. So hypothesis, setting up the hypothesis, you can do only in EDA. Then model selection and algorithms understanding, improving the model performance and communicating the results, okay, or the insights. Insights mean the findings. So communicating the results and findings to the users. So this is the reason. Okay, all these things you can do, you can achieve only by using EDA. So EDA is very important for data science. Question number 4. Why is making sense of data important for EDA? Okay. So making sense of data in EDA is very important. It's very crucial because it lays the foundation for all subsequent steps. So what are the steps available in the data science? Okay. So the EDA is going to be the first step. So it is a foundation for all the subsequent steps in the data analysis process. The reason why data is important means, okay, these are all the reasons. Already we know these reasons. We already studied this reason in question number 1, 2, and 3. We can see here, understanding the data characteristics. So data characteristics means what? About the data. What is that? The structure of the data, the type of the data, and the distribution of the data. So all these things we can study by using EDA. Then detecting the patterns and the trends. What is a pattern of that means how the data is going. What is a trend available in the data set. Then the quality of the data set. Okay, hypothesis development, improving the model performance, and communicating the insights. So these are all the reasons why data is important in EDA. So by using EDA, we can understand all these things about your data set. Question number 5. So how does EDA contribute to the data science projects? So EDA is a foundation. Okay, that means a fundamental step in the data science projects or in data science. So playing a crucial role in ensuring the success and the effectiveness of the entire workflow. So if you need your data science flow, okay, or if your data science project should be a successful one, you have to go for the EDA. So EDA contributes in the data science. So this is the contribution of the EDA. So already we studied this in the previous questions. Okay, understanding the data set. Okay, data cleaning and preparation, identifying the patterns and the relationships, feature engineering or selecting the features. What is feature and all you will understand in the coming questions. Guiding the analytical focus, improving the model selection and performance, reducing the risk, and communicating the insights or the results. So the points almost are repeated, okay, because this is a 2 more question. The questions almost are repeated. Okay, the concept is same, but the question they are framing in a different way. So this is question number 6. List the various stages involved in EDA. So this is a very important question. Okay, for in the short answer also, and also in the long answer. So in the long answer, if you see this question, you have to explain all the steps, all the 5 steps you have to explain, and you have to draw a diagram for that. So this is 2 more question. Only if you write the steps and a very simple definition if you give, it is enough. Now, what are the steps available in EDA? So totally there are 5 different steps available. The first one is a problem definition. Second one, data collection. Third one, data analysis. Fourth one, model development. And fifth one is a result communication. So these are the 5 different steps of EDA. So let us see each and everything, all the steps one by one. Okay, problem definition means clearly you have to define the problem and also the objective. Okay, what you are going to solve, what you are trying to find. Okay, the objective should be very clear and the problem should be very clear. So this is problem definition. Second step is the data collection. So collecting the data needed, whatever the data you want. Okay, it could be a data set or it could be any file, whatever it is. So you have to collect the data from the appropriate sources. Collecting the data. It is a data collection. Third step is the data analysis. So once the data is collected, then you have to find, okay, what is the data structure. That means you are going to study about the data, how the data is organized, okay, what are the fields available, okay, etc. Then the quality of the data set, okay, what is the quality? Suppose if it needs cleaning, you have to do the cleaning. Okay, if you don't want cleaning, you can just directly use it. So finding the quality of the data set and finding the pattern. So what are the patterns followed in the data set and the relationship between the variables. So this is third step, data analysis. Then the fourth step is a model development. So you can prepare and optimize the data. Okay, so prepare and optimize the data for a predictive or an explanatory modeling. So for a predictive, to identify the future data or to forecast the data, so you have to prepare your data. Then the result communications. So finally, present the findings, whatever the findings, or we can say it is the insights through the visual and the reports. So these are all the 5 different steps available. It's a very important question. Question number 7. What visual aids are commonly used in EDA? Or list the techniques for visualizing data in EDA. So it's a very important question and it's a long answer question also. So here in short answer question, simply we are going to list out what are the visual aids. So you no need to explain everything. Okay, if you just write the list is enough. But if the same question is asked in the part B means you have to explain each and every visual aid, okay, with an example. If it is possible, you can give a Python program also. Okay, now visual aids are very important in EDA. They provide intuitive ways to explore the data. That means the visual aids used to explore the data. They used to detect the patterns. They used to uncover the relationship between the variables, and then they used to identify the anomalies. So what are the visual aids available? Okay, in EDA means a very big list is available. You can see here histogram, box plot, scatter plot, line chart, bar chart, heat map, pie chart, violin plot, pair plot, bubble chart, tree map, word cloud, okay, density plot, radar chart, or we can say spider chart, okay, stacked bar chart, and 3D scatter plot. So these are all the visual aids available, okay, for EDA. Now, in 2 more questions, if you simply just write the list, it is enough. Okay. But if the same question comes in the part B means, so you have to explain each and every visual aid. Okay. Histogram means what is histogram? You must draw a diagram, histogram diagram. And if possible, you can give a small program, a piece of Python program should be written. Okay. So this is how you can solve this particular question. Okay. Now, let me just give you a very brief introduction for each and every two. Okay, I'm going for the histogram. So histogram generally used for understanding the distribution of a single variable. Okay, it's not going to compare any more than one variable. Okay, only single variable you can convert into bins and you can find the relationship between that. So that is a histogram. The second one is a box plot. Box plot is very important one. Okay, even in the 2 mark question you can expect. Okay, write about the box plot. Okay, so box plot, it gives many information. Okay, like what is the median, okay, the quartile value, first Q1, Q2, Q3. So all the values will be given in the box plot. Okay, in the next question, I think we are going to see about the violin plot. So the violin plot is completely based on the box plot. So box plot is a very important 2 mark question. So here you can find what is outlier, okay, the outliers, then you can understand the spread of the data, okay, how the data, that means what is the minimum value, okay, what is the maximum value, okay, everything, okay, the skewness of the data, everything you can find it by using a box plot. Then scatter plot for 2 variables, that means you can find the relationship between 2 continuous variables, we can find the relationships. Line chart, okay, so this is also analyzing the trend, Okay, so over a period of time, or another sequential variable. Then bar chart. So the bar chart, it is a categorical data. It is used for the categorical data to compare the categorical data and to analyze the frequency or the proportions. So heat map to visualize the correlation between the variables. So two or more variables you can take, and it will be in the form of a grid. Okay, it will be in the form of a box. Okay, like a grid. Grid means like box squares. So you can visualize the relationship, that means the correlations between two variables. So pie chart, it is going to be the percentage. It will be in the circle form. Okay, and you can see the proportion of each element or each variable. Okay, 10%, 20%, okay, like that. Then violin plot, as I already told, violin plot will be constructed by using the box plot. So it's a very important one. Violin plot, box plot. The next question is going to be the violin plot. Then pair plot, so it's a pairwise relationship. So if you are having more than one variable, so you can compare as a pair. So first variable, second variable, third variable and fourth variable, fifth variable and sixth variable, so you can compare like a pair by using the pair plot. So bubble chart, this is also for visualizing the relationship between the three variables using the size to indicate the magnitude of the third variable. So what is the magnitude of the third variable? We can analyze by using the bubble chart. Then tree map. So this is a hierarchy data. The hierarchical constructions you can do. Okay, so represent the hierarchical data with nested rectangles. Then word cloud. So this is okay for the text data, textual data, and you can find which word is okay repeated how many number of times. So that is the word cloud. Okay, the next one is a density plot. So this is exploring the distribution of a single continuous variable. Okay, a single variable which continuously the data is available means you can go for a density plot. Radar chart, it's a multivariate data analysis. Okay, this is your lecture number 5. Okay, multivariate data analysis, and it is used in the multivariate analyzing the multiple data more than two. Okay, so stacked bar plot, it shows the plot for the different categories over the time or across the groups. So stacked means like it will be converted like for 100%. So first variable is how many percent, the second one contribution is what, the second third variable's contribution is how much. So you can convert as a single and stacked. Then the next one is 3D scatter plot. So definitely three variables will be available here. So using the three variables, you can make a three-dimensional plots. So these are all the visual aids available. Okay, and you can use any of this for your ADA. So as I already told, if it is in the 2 mark question, so just you can list out the plots and you can give a simple definition. If it is a long answer question, that means a part B question, so we have to explain each and everything with an example diagram and also a Python program. Okay, so this is about the question number 7. Now I'm going for the next question. Question number 8. What is the role of visual aid like violin plot in EDA? So we are just going for the violin plot. So we are going to write what is the role of a violin plot, okay, in EDA. So first what you do, first you see the violin plot first. So this is a violin plot. As I already told, a violin plot is constructed based on the box plot. Okay, this is a box plot. Inside this, we are having a box plot. So on the box plot only, the violin plot is given. So what are the things you can get from a violin plot means? Okay, you can see for any data, okay, or any data set. So you will get what is the minimum value, what is the maximum value. Okay, that is a Q0, Q4. Then the first quartile, what is the median value? Okay, the third quartile. Then what is the density? Okay, the density plot also you can get. That means the frequency also you can get. So in a single plot, so many informations you are getting. What is the minimum value? What is the maximum value? What is the median value? Okay, so what is the quartile value? First quartile, second, everything we are getting. Even outliers you will get. Suppose if the data is available here, so we can say it is an outlier. Okay, so the outlier also you can get it from this particular chart. So this is about the violin plot. You can see the theoretical part here. A violin plot is a data visualization that combines aspects of both box plot and KDE, kernel density plot. Then it provides more detailed view of the distribution of the data set. Okay, what it is going to show, showing not only the summary statistics. What is summary statistics? You will understand in the coming slides. There will be 5 values: minimum, maximum, okay, median, mode, range, all these things. Then like medium and quartiles, but also the probability density of the data across the different values. So it's a combination of box plot and the kernel density plot. Then understanding the data distribution. Okay, you can understand how the data is distributed, what is the minimum value, maximum value, all these things. Then you can identify the outliers. I already explained in the last slide. Then comparing the groups of data, spotting the multimodal distribution, where the data is distributed more, where the data is available less. Then enhancing the insight and improving the communication. So the last 2 points is a common point, but the first 4 points are very, very important. So data distributions you can understand, outliers you can find, you can compare the groups, and you can find the multimodal distributions you can find. So this is about the violin plot. So this is an example for the violin plot. Then moving on to the next question. The next question, question number 9, is a scatter plot. So now let us see a scatter plot first. So this is a scatter plot. So what is this plot shows means it is comparing two variables, okay, x and y. So how the data is scattered, okay, it is given here. So here also you can identify the outlier. Suppose I'm considering this data is outlier, and you can find the clusters. Clusters means where the data, more data is available. For example, I can say this is cluster 1. Okay, so where the more data points is available, and I can say this is the second cluster. Okay, and this is the third cluster. So where the data, more data is available, you can find it. Okay, what is the minimum value, you can find it. So this will be the minimum value, and this will be the maximum value. Okay, so like this you can compare two values, two variables, and you can get a lot of information from the scatter plot. Now let me go for the theoretical part. A scatter plot is most useful in the following scenarios. So when means analyzing the relationship between two variables. So you can compare two variables, okay, x and y, and you can find what is the relationship between these two variables. Then you can identify the trends or the patterns. So whether it is a positive, negative, or no correlation. So using this, you can find the correlation between the two variables. Okay, I'm not giving that. I'll give it as a separate question. So positive correlation, negative correlation, and then no correlation also you can find it by using the scatter plot. Then next one is just plotting the clusters. I already told you. So the groups where the data is available, more data is available, you can find the clusters. Then detecting the outliers. So the data which is not coming either the minimum or the maximum. Okay, that they are called the outliers. The outliers we can find it here. Exploring the variable interaction. So that means useful for examining how two variables interact or affect each other. How x is affecting y, or how y is affecting x. Okay, so these values also you can see by using a scatter plot. Then comparing multiple categories. So with color coding or different markers, scatter plots can compare the relationship across the categories. So here we have only one category. I just put everything in one category. So you can have two different categories of data, three categories of data you can have, and you can make a scatter plot. So it's a very important short answer question. Okay, so when is a scatter plot most useful? Now moving on to the next question, question number 10. It is a lollipop. Define a lollipop chart and provide a sample graph. So let us see the lollipop graph first. Okay, so lollipop chart. So this is a lollipop chart. So here only one variable. So we are not going to compare any variables. Only one variable which is having different categories. Okay, for example, so this is my data. Okay, this is my data. Okay, a single data. I have different categories in that. So A is one category, B is another category, C is another category, D and E. And this is the value of A. So the value of A is 4. So value of B is 7. Value of C is 1. Value of D is 8. Value of E is 5. So I'm just going to make this as a circle. Okay, and then I'm going to draw a line till x-axis. So this is called a lollipop. Okay, lollipop chart. Now, so we'll see the theory part here. A lollipop chart is a variation of a bar chart. So it's almost like a bar chart. Okay, single variable, categorical variable. So where the lines are drawn from a baseline. Okay, baseline is the x-axis to the data point. That means what is the value of that point. So from the base, from the x-axis to the value. Okay, we are going to draw a line and we are going to make a circle represented by the circles, or we can say other markers. So I don't want circle, I can go for another marker. Okay, you can make it. I want to make it a star. I want to make a square, rectangle. Okay, whatever it is. So it's particularly used for comparing the data points while maintaining a clean and a minimal value design. So the lollipop chart will be a very clear one. So only one data. Okay, but it is having different categories. That's it. So when to use the lollipop means comparing the values across the categories, different categories. In highlight the magnitude of the individual data points without the visual weights of the bar. So magnitude means the height. Okay, for example, easily you can understand what is the magnitude of B means it is 7. What is the magnitude of D means it is 8. Okay, so this is a use of a lollipop chart. The next question is, what is a pivot tables? Okay, pivot tables. How do pivot tables aid in EDA? So it's a very important concept. This also. Okay, so if you're clear with these two more questions, easily you can write part B questions. Okay, so watch it very carefully. Now, how do pivot tables aid in EDA? Okay, before going for all this theoretical part, we can go for an example. I'll show you an example for a pivot table. So what is a pivot table? If you understand, the things will be very easy. Or what is the meaning for the word pivot? Means the meaning for the word pivot is a summary, or we can say it is a core, central, okay, attractive. There are so many meanings available for this word pivot. Now, this is the given table for me. So what is available here means gender is available, age group is available, they purchased or not. Okay, the data is given here. Now, if you see this, I cannot understand. The data is available, but we are not getting any, what to say, a conclusion or insight we are not getting from this. So, I'm going to convert this particular table into a pivot table. Okay, so this is the pivot table I'm converting. So, if you convert into a pivot table, so it will convey some message to you. Okay, so it will give some insights to you. So, what is that? I'm aggregating by the gender, then I'm aggregating by the age group, showing the count yes and no. So what I'm doing, so here the gender is mixed. Male is available, then female, female, male, male, female, female, it is mixed. So what I'm going to do, I'm just going to arrange this in a order. Okay, so female, female, female. Then I'm going for the male, male, male. Then, so in the female, I'm going for the correct age group. Okay, 18 to 25, 26 to 35, 36 to 45. Same for the male also, I'm going to organize the, okay, in the, according to the age group. So 18 to 25, 26 to 35, 36 to 45. Then I'm going for each age group, whether they purchased or not. So you can see here purchased 2 times, yes. Okay, then automatically this is going to be 0. So here female from the age group of the 26 to 35, they purchased once. So in this group 36 to 45, they purchased once. Okay, so here male in the age group of 18 to 25 purchased one. So from this table, I'm converting this table like this. So this is going to be a pivot table. Now we are getting some information from this. What information I'm getting here? Okay, you can see here. So I'm going to see female from the age group of 18 to 25. So they purchased 2 times or 2 items they purchased. Then female in the age group of 26 to 35. Okay, so they now purchased, no purchase. So in the age group of 36 to 45, okay, no purchase. So we are getting some meaningful information from this particular table. This is called a pivot table. But in this table, the data is available, but giving the insight, whether this table is giving any insight to you means it's not giving. So once if it is converted into the pivot table, you can understand this data. So this is pivot. Now you can go for the theoretical part. How do pivot tables aid in EDA? Okay, so how do pivot table helps in EDA? Okay, now, so these are all the points. Data summarization. It summarizes the data. That means it aggregates the data by grouping and summarizing. So you can use the metrics like sum, mean, count, median. Okay, anything you can use. So in the previous example, we are using the sum. Okay, we've summed the number of purchase. Then flexible groupings. You can group the data. Yes. So here we group the data based on the gender, then based on the age group. Okay, then based on the purchase yes, based on the purchase no. Okay, but in the original table, just purchased is available. Age group come mixed. Okay, gender is also mixed. So we are making, okay, we just divide the purchased into 2, like yes and no. Okay, so this is the categorizing the data. So if you categorize the data, you will get more information. Then comparing the metrics. So we are comparing the male with the female here. Okay, age group we are comparing. Okay, so purchased or not, all these things you can compare. Then identifying the trends. So what is the trend going on? Whether the people are purchasing or not, or who is purchasing more, who is purchasing less. So you will find the trend from this particular table, pivot table. Then spotting the outliers and anomalies. If there is any outlier, or if there is any anomalies, so easily you can find it. Okay, so if you see in this table, okay, I think there is no anomaly. Almost everything is normal. Even female is purchasing and male is also purchasing. So in the age group, different age groups, they are also purchasing. So if there is any outlier, you can find it very easily by using the pivot tables. Then feature engineering. So this generates a new aggregated features. It can be used for modeling, such as the total sales per customer, so to average purchase size. Okay, so what is the total number of items purchased by male, total number of items purchased by female, total number of items purchased by female in a particular age group. So different features you can create from that, you can extract from that. And this table is used for a very quick analysis. So it's more need for the extensive coding or calculations. And then the tools, like you can use any tool. Okay, for calculating, for finding the pivot table, you can use Python. Okay, you can use a Python or you can use Excel. Okay, so using any tool you can generate the pivot table. So this is about the pivot table. Please keep it in your mind. It's a very important thing for long answer question also. Okay, for B also sometimes they will ask, okay, write about the pivot table with the example. So you can give the same example and you can write it. Question number 12. Why are pivot tables and cross tabulations useful in summarizing data? So we already discussed about pivot tables and we gave an example also. Now we are asking about cross tabulation also. That means the next concept is introduced here. Okay. First we have to know what is cross tabulation. So cross tabulations means, okay, we can say cross tabulation or we can say contingency table. So if you go for lecture number 4, okay, so we'll talk about the contingency table in depth. Now, so using the contingency table or we can say the cross tabulations, okay, you can count. It counts the frequency of the combination of two or more categorical values. So there will be some counting will be used here. So we'll see the example. But in the pivot table, so it is going to summarize, it's going to organize and summarize the numerical data, and it is going to group the data and aggregating the data. So if you see an example, you will be very clear. You can see I'm taking the same example, which we already discussed. So this is the given table. So the table is not in a very clear form. Okay, data is available, but we cannot understand anything from this. I'm converting this into a pivot table here, and then I'm going for a cross tabulation here. Okay, now, so already we discussed this pivot table. So based on the gender, first we are categorizing it. Okay, we are arranging it. So all the female I'm bringing here. Then I'm going to bring all the male. Then the age group, okay, 18 to 25, 26 to 35, 36 to 45. Again the age group. Then purchased, not purchased. So we are arranging the data in a particular order and we are bringing the summary here. The same thing we are doing, but you can see what is a cross tabulation means. In a cross tabulation, okay, you are going for the frequency of the gender versus age group. So now I'm taking the gender and I'm taking the age group here. Now, so gender male, okay, male. So 18 to 25, okay, the number of people purchased is 1. So from in the age group of 26 to 35, so in the case of female, okay, the number of purchases 1. So I'm making a cross tabulation like this. So the cross tabulation also it will summarize the data, but it will give the clear count. Okay, so either the pivot table or the cross tabulation. So what is the purpose of this? It is summarizing the data and it will give the insights. So easily you can understand what is available in the data. Now you can see the difference here. Okay, pivot tables organize, summarize the numerical data by grouping and aggregating it based on the categorical values. So cross tabulation, what is happening means we can say it is a contingency table. It counts the frequency of the combination of two or more categorical variables. Now, so both the pivot tables and cross tabulations are very powerful tool in data analysis because they simplify the process of summarizing the large data set. So it provides a very clear insight, the relationship between the variables, and easily, very quickly you can explore the data, you can understand the data. Okay, so they are indispensable for understanding the trends, making the comparisons, and supporting the decision making. So the meaning, what is that meaning of indispensable means? In Tamil, it is தவிர்க்க முடியாத. Okay, so this is how the pivot table and cross tabulations are used for summarizing the data. Now, so depending upon the part. Okay, if this question is asked in the part A, you can answer in such a way. If the same question is asked as a 8 marks or 16 marks, so you have to elaborate the things. Okay, that is in your hand. Now, I'm going for the next question. What are the types of mergers used in EDE? Okay, so generally merging is very, very important. So what is merging means? You will be having two different data set. Okay, for example, this is one data set and this is another data set. I'm having two data set. Now these two data set I want to merge. I want to combine together. So how can combine? That means by using the concept of merging, I can combine the data set. So this is the concept of merging. Now, what are the types of merges available? So there are basically four different types of merges available. So you might have studied this in the database course also. Inner join, left join, right join, and then outer join. Okay, so we'll go one by one. So what is inner join means? That means the data combines only the rows that are matching the values in both the data set. So which is matching or which is available in both the data set. So in data set A, data set B, so which is available in the data set in both the data set, that is called the inner join. I'm going to take only this data. Okay, so this is data set A, data set B. So we are going to take only the data which is available in both. So that is the inner one. The next one is a full. So we can go for the full or outer join. So what is this means? Combines all the rows from both the data sets. Okay, so filling in missing the values with NaN where no match is found. So suppose if any data is not available, not a number, NaN means not a number. If the data is missing also, it will automatically fill. It will take from right side or from the left side. Okay, so all the data from both the data set I'm going to take. So this is called a full or outer join. Then, so what is a left join? Okay, you can say this is a left join. Keeps all the rows from the left. Okay, so from the left, I'm going to keep all the data from the left and the data which is matching, okay, between A and B. So I'm going to take this particular part. So this is a left join. So right join is the same thing, right side. So keep all the data from the right and the data which is matching from A and B. Okay, for both A and B, the common data we are going to take. So these are the four different types of merges available in EDA. The next question is, what is the purpose of merging the database? So in the previous question we saw, okay, what are the different types of merging? So why we have to merge? So what is the purpose of merging means? Okay, you can see here. So there are 5 points given here. The first point says combining the related information. So the data is scattered. Some data is available in data set A. Some data is available in data set B. So I want to combine. So if I combine, then only I'll get a complete data set. Okay. So combining data set gives different types of information but related to the same entity. So the first point is combining the related information. Then enhancing the data completeness. So this is another very important point. What does it mean? In one data set, the data will not be complete. Okay, in another data set, the data may be completed. So if you merge both, automatically the complete data set you will get. So merging can fill in the missing pieces. Whatever the pieces which are missing in one set, it can be filled by using the another piece. So enhancing data completeness. Then facilitating deeper analysis. So you will get richer data set. That means your data set will be more rich. Okay, if you are combining. Combining data set allows for a richer analysis by enabling cross variable analysis. So some variable will be available in A and something else will be available in B. So if you are combining both A and B, your data set will be very large and you can do a very deeper analysis. Creating the new features, the same thing. So in data set A, some features available. In data set B, some features available. So by combining these two data set, you will have more number of features. Okay, so this is the creating the new features. Then resolving the data inconsistency. So data inconsistency is a big issue. Okay, so the data will not be completed or data will be duplicated. So these are all the problems available because of data inconsistency. So data set can help to resolve the inconsistency problems or missing data. Okay, the data which can be, for example, x equal to 10 in one place, x equal to 20 in another place. So how can I solve this problem? Means, so you can go for the another one. Suppose another data will be available for another value will be available for x. So you can take that one. So the data inconsistency problem can be solved. Okay, data duplication problems will be solved. Okay, so these are all the advantages of merging the data sets. Okay, combining the related information, enhancing data completeness, facilitating the deeper analysis, creating the new features, resolving data inconsistencies. Then the next question is define transformation techniques in ADA. So transformation first, going before going for the transformation techniques. So we must know what is transformation. Okay, so what is data transformation in ADA? So data transformation means, okay, you can see here, it's a technique encompasses various methods used to convert, okay, you're converting a raw data into a clean and usable data set. So a raw data set will be cleaned, okay, and it will be usable, and it is making as a usable data set. So this technique comes in different forms. There are different forms available or different methods available. So each offering a different approach. So there are different approaches available, okay, for data transformation, and not all may be necessary for every project. So you can select some transformation technique. You no need to use all the transformation techniques. Okay, so the basic thing is it is going to clean your data and convert the data into a usable data set. Then some of the fundamental data transformation techniques that can be applied to the analysis projects are, okay, you can see here, these are all the different types of transformation techniques. So handling missing data, handling categorical data, feature scaling, okay, handling outliers, feature engineering, logarithmic and power transformation, dimensionality reduction, time series data transformation, date and time features, text data transformation, encoding numerical values. Not only this, the list is a very big list is available, different transformation techniques. Okay, but here we are just giving the list, the complete thing. In this, in our course, we are studying some of the transformation techniques. Okay, for example, how to handle the missing data, handling the categorical data, scaling we are studying, outliner we are studying, features we are studying, logarithmic and power transformation we are studying. Okay, I think this is in lecture number 3 or 4. So time series we are studying in the last lecture, lecture number 5. So many transformation technique we are covering in the course, in our course, that means in this subject. Then the next question is data smoothing. What is a data smoothing, and give the types of algorithms used for data smoothing. Okay, now first try to understand what is smoothing. Okay, smoothing is nothing, it's a technique to reduce the noise in the data set. Okay, to reduce the noise in the data set. Noise means unwanted things, or we can say it is a error or unfilled data, incomplete data, duplicate data. So whatever it could be, it's a noise. Okay, abnormal data. Okay, so reducing the noise in a data set, then facilitating the identification of the trends. So two things, okay, the smoothing is going to do. So it will help us to identify the trend, and also it is going to reduce the noise. So noise can adversely affect the data. Yes. So minimizing the noise is very, very important. So one can derive a clear insight and uncover the patterns that might otherwise go unnoticed. So removing the noise is very, very important, or at least we have to minimize the noise. Then only, okay, you will get a clear insight, okay, clear picture of your data. Okay, otherwise it will be very difficult. You will interpret your data in a wrong way. Data interpretation will be very wrong if you have a noise. So reducing the noise is very important. Then, what are the algorithms available? So there are three basic algorithms available here for data smoothing. So one is a clustering algorithms, second one is a binning algorithm, and then third one is a regression. So clustering means, okay, the word clustering here, okay, directly it says that you can make the data into groups. So grouping similar values into clusters. So destinating many values outside these clusters as outliers. If any data which is available outside the group, we are going to say it is outlier. Okay, so outlier is a very important word here. What is outlier means? Which is not coming under any group. Okay, that is called the outlier. Then binning. So what is binning means? You can divide the data into some groups. Okay, so divide the data into bins. Okay, for example, if you take a classroom. So in the classroom, okay, the marks, the students have scored the marks in a subject. So I'm going to create the bin. So I'm going to have 10 bins. So what is the 10 means? 0 to 10. This is bin number 1. How many students available within this range? Then 11 to 20, 21 to 30. So 31 to 40. So this is called the binning concept. Okay, so binning is also a very important data smoothing method. Then regression. So you can use the regression algorithms, okay, to determine the relationship between the two variables, two different variables, allowing for the predictions and one attribute based on the value of the another one. So finding the relationship between the two variables. So based on one, you can identify or you can forecast the next one. Okay, that is the use of the regression. So data smoothing means what? You must be very clear. Then what are the three different types of data smoothing? Okay, clustering, binning, and regression. The next question is, what is attribution construction? So very simple. Okay, you make it in a very simple way. So what is attribution construction means? Creating a new variable or creating a new what to say, a field. Okay, or in a way we can say creating a new feature. Okay, a new feature will be created. So this is what attribution construction. Okay, for example, you can see here. So in my data set, I have already, there are two variables or two fields, okay, or two columns, two attributes available. So one is a called impression and second one is a cost. Now, I want to compare this impression and cost. Two things I want to compare. So what I'm going to do means, I'm going to combine these two things and I'm going to make a new attribute I'm going to create. So I'm going to call it as CPM. So CPM means cost per million impressions. So what is the concept here means impressions is a variable here, it is having some value. So to get that impression, okay, what is the amount I spent? So I'm combining both together and I'm going to make it as a CPM. So by using the CPM, I can find, okay, what is the exact thing is going on in the system. Otherwise, I will give you a simple example for you. Okay. So what is this means? There are 5 subject mark available. Subject 1, subject 2, subject 3, subject 4, subject 5. 5 subjects mark is available. Then for all the 5 subjects, I'm having the grade. Okay. For example, A, B, C, D. Okay. Some grades are available. Now, I cannot find who is the best student in this case. Okay, so we cannot find. So what I'm going to do means I'm going to combine all these things and I'm going to make it a new field which is called the CGPA. Okay, so what is your CGPA? So based on the CGPA, I'm going to identify who is the best student. So this is how, okay, the attribution construction is working. So based on the grade, individual grade. So in the first subject you got grade A, second subject you got grade B, and third subject again A. So the students are getting like this in a mixed way. So we cannot identify who is the best student. So go for the CGPA, cumulative grade point. So based on that, I can identify who is the best student. So this is construction of attribution. So attribution construction is widely used technique in the data transformation pipelines. It is also known as the feature construction. So creating a new field, creating a new feature. So it involves creating a new feature from the set of existing attributes in the data set. So already available. So impression is already available, cost is already available. So using this, I'm creating a new attribute and it will be used for easy like decision making. Okay, it will give the clear insight of your data set. So this is attribution construction. The next question is data generalization. Okay, for example, you can see I have 4 attributes here. Okay, the first one is the city, second one is the street, country, and then state or provinces. Now, so this data or these fields, I'm going to arrange it in a hierarchy order, in a correct order we are going to arrange. Now, I'm going to arrange like this. Okay, for example, the street should come first, then city, then state or provinces, and then finally it is going to be the country. So all the 4 attributes or the 4 fields I'm arranging in a particular order. Okay, that means in a hierarchy order I'm arranging. If you do like this, and I can give a common name for this, the common name is going to be the address for this. Okay, so if you do like this is called the generalization. So which is the low level attribute, which is the high level attribute. Okay, all the attributes will be arranged in a proper order. If you do that, that is a data generalization concept. See, data generalization is a process of converting low level attributes into the high level attribute. Okay, once using the hierarchy structure. So typically apply to a categorical data with a finite extensive number of distinct values. So these are all different categories. City is a category, state is a category data, country, okay, everything. So we are arranging these in a particular order and we are making as a generalized one. So that is called a data generalization. The next question is data discretization. Okay, so this word is coming from the discrete. Okay, the word discrete mathematics or discrete. So what is discrete means the data is not going to be a continuous one. Okay, so here the data we are going to cut into pieces. Okay, we are not going to have the data in a continuous way. So this is called data discretization. Okay, so you can see here data discretization is a process of transforming continuous data. Okay, the data which is coming continuously, we are dividing the data into buckets or interval. So discrete buckets or intervals we are dividing. So this technique is commonly used in data pre-processing stage, particularly for the machine learning. So if you're going for the machine learning, so definitely you need to do the data discretization. Then, so this will be very useful for analysis of continuous attributes and enable the categorical analysis. Then, what is the objective of discretization? Means simplifying the data. So, if you have a very continuous data, so analyzing the data will be difficult. So, we are going for the grouping. So, we are converting the large continuous data set into smaller bits. Then, improving the model performance. So this is related with the machine learning. As far as the machine learning is concerned, so you have to go for the data with, like what to say, the continuous data providing to the machine learning models will be difficult one. So we can divide the data into pieces. Then enhancing the interpretability. So easily, it will be easy to interpret the data. That means the what to say, the insights. Getting the insights will be very easy if you are going for the data discretization. Okay. Now, in this, there are some methods available. Okay. So this could you can expect this question in 8 mark also. Okay, so data discretization methods. So what are the different methods means? Probably there are 5 methods available. The first method is equal width binning method. So okay, so this binning already we studied. What is binning? So in histogram we have bins. So dividing the range of data into bins of equal size. Okay, for example, I have the data from 0 to 100 means I'm not going to handle it as a single piece. So what I'm going to do, let me convert into 4 bins. So 0 to 25 is 1 bin, 26 to 50, 51 to 75, 76 to 100. So we are dividing it into bins. Then equal frequency binning, the same thing. Okay, for 100 data points, create 4 bins with 25 data points each. So if you have 100 data, so for each 25 data, I am going to create a bins. Then clustering based discretization. So clustering means there are different algorithms we can use it here. So using k-means algorithm. So these are all you will study in machine learning concepts. So clustering means grouping the data. So based on a common property, you can group the data and you can make it as a separate groups. Then binning. So again, custom binning is available. It's equal binning and custom binning. So in the equal binning, okay, there will be equal space. Okay, the frequency will be equal. So 25, 25, 25 we are dividing. But in the custom binning, you can have your one from 0 to 18 I'm having. So 19 to 35, 36 to 60, 60 to 60, sorry, above 60. That means 60 plus. That means the age we are dividing like this. Decision tree based discretization. So this is, they will have some tree structures. So based on the tree structures also, you can divide your data. So these are all the different types of data discretization. You can expect this either in the 8 marks or in the 16 marks also. So you have to explain this using some examples. Next question is data normalization. This is a very important concept as far as EDA is concerned. So you must be very clear about this concept. What is data normalization? So what is data normalization means? It's a process of scaling the data into smaller range without losing the information. Okay, so I'll give a very simple example for you. So you are getting marks in different subjects. Okay, 70 mark, 80 mark, 90. So you're getting different marks. But finally, okay, so after completing 8th semester, so you are going to you'll get a CGPA. There is something called a CGPA. So what is CGPA means? So it's going to be in the range of 1 to 10. Okay, so all your marks, they convert everything, they just do some calculation and they convert it into, okay, like 7.5, 8.5, 9.2, 9.1. So they're converting and giving a okay a CGPA to you. This is called data normalization. So scaling the data to a smaller range without losing the information. So what is the use of this means? So this helps in minimize or to eliminate the duplicate data and to enhance the algorithm efficiency. Okay, so whatever the algorithm processing your data, the efficiency of the algorithm will be improved by this by using the scaling concept and then data extraction performance. Now you can see there are three different methods available for data normalization. The first one is called min-max normalization. So the word itself it is very clear, minimum and maximum. So this method applies a linear transformation method, okay, to your data. I think it is available in lecture number 3. Then Z-score normalization. So this is also known as zero mean, okay, by using the mean and standard deviation. So this normalization will be done by using the mean value and also by using the standard deviation value. Then decimal scaling is okay dealing with the decimal points. Okay, so you can have 2 decimal points, 3 decimal points, or you can remove the decimal points. Okay, like that. So adjusting the decimal points in the value. So these are the three basic types or three methods of data normalization. Now, let me go to the next question. What is the use of a group by function in pandas? So already we know pandas is a very powerful mathematical library, so which can use for all the mathematical uh, manipulations or mathematical calculations. You can use the pandas. So now group by function in pandas is used for grouping the data. Okay. So if you group the data, what is the use? We'll see it later based on one or more keys. So one or more field or one or more value, okay, whatever it is, apply the aggregation, okay, transformation, filtration operation on the grouped data. So once if you group the data, you can do all this too. Okay, all this thing. You can do the aggregation, okay, you can do the transformation, and you can do some filter operations. Now, so pandas is a very powerful mathematical tool which can be used for the data analysis and manipulation, often used for the operations like summarizing the data, calculating the statistical values, then creating the pivot structures. Okay, pivot table we can, or consistency table you can create. Okay, so all these things we can do. Now, key features of grouping. So if you group the data, what you can do means the first thing you can see here. So grouping, aggregation, transformation, and filtration. So these are the four important key features of group by. By using group by, you can do all these things. Okay, I'll go one by one. So what is grouping means? So you can group the data based on one or more columns. Columns or fields or attributes or okay. So you can use any word. Okay, okay, fields, keys, attributes. Even you can use the word features. Okay, so based on anything you can group the data. Not only one field, you can have more than one column also. Okay, this is. Now aggregation means once if you make it into groups, you can easily find all these things. You can find the sum, you can find the mean, you can find the count, okay, minimum, maximum, all these values for each group easily you can find it. Then by using okay the group by, you can do the transformation. So once if you group the data, automatically you can apply the transformation for each group and returning the okay a data frame with the same size as the original. So what is transformation? We already studied. Okay, so using the transformation techniques, you can transform the data. You can scale. Okay, you can minimize the data to a particular value, a range. Then filtration. So filtration is you can apply a condition. So based on the condition, okay, whatever the data comes, you can remove the data. Or if it is not following the condition, we can remove the data also. Okay, anything. So you will get some result. If you apply some filter, you will get some result. That result, that data, okay, you can keep it or if you want, you can delete it. So filtering groups based on a condition, okay, retaining only groups that satisfy the condition. If it is not satisfying the condition, remove the data. So that is the concept of filtering. So grouping, aggregation, transformation, and filtration you can do by using the grouping concepts. Now, so these are all use cases. So where we can use, okay, you can see summarizing the data means so summing, finding the average, counting the data, comparative analysis, okay, data reshaping, and then custom operations. So for all these cases, you need group by.